ओके सो आज मैं अनदर प्रॉब्लम डिस्कस करने वाला हूँ जो कि TIFR 2021 का ही PYQ है। और मैं ये वीडियो इंग्लिश में करना चाहता हूँ क्योंकि मतलब एक दोस्त ने मेरे को बोला कि हाँ आपको इंग्लिश में ही करना चाहिए क्योंकि मतलब इंग्लिश में ही सभी एग्ज़ाम्स होते हैं, तो मैं भी यही सोच रहा हूँ कि हाँ इंग्लिश में ही ठीक रहेगा क्योंकि आपको मतलब आगे के लाइफ में एकेडमिक जो भी कम्युनिकेशंस हो गए इंग्लिश में ही करना पड़ेगा। मैंने पहले कुछ वीडियो इंग्लिश में बनाए थे लेकिन फिर लोगों ने बोला कि हिंदी ज़्यादा अच्छा है, इसलिए हिंदी में बनाना शुरू कर दिया। लेकिन मुझे लगता है कि मुझे इंग्लिश में ही कंटिन्यू करना चाहिए इसके बाद। अगर आपको क्या ठीक लगे आप वो कमेंट कर सकते हो। Okay, so let's start today's video. So this question says there is a oscillating dipole PT is equal to P naught cos omega t z hat generates a time dependent electric and magnetic field at distances r from the dipole. So this is the form of the magnetic vector potential, and you have to calculate the total radiated power from this dipole. ठीक है. Okay, so this kind of problem are actually easy because most of you, some of you don't read this ED2, this radiation part. They are in the second semester of last semester of MSc. So most of you didn't read these topics very well, but these are actually scoring parts. Okay, so and they are not very difficult. They are actually easy. Okay, so let's try to solve this. So this is the configuration, and another thing I want to mention, that please pause this video and give it a try by yourself. It will boost your confidence. Okay, so give it a try yourself first, pause the video, and after that you can check that or watch the solution if you don't solve it. Okay, so not p not omega by 4 pi r into sine of omega t minus r by c. Okay, so this is the form and this is z hat. This is very important. Okay, so now this is a and we have to find the power. So the first thing for and most important thing for this problem, to we have to take derivatives. We have to take the radial direction because power is this is the oscillating dipole at origin, and if you read the theory a little bit, you know that power is radiated uniformly in radial direction. So we have to go to in spherical polar coordinates. Okay, so we have to convert this z hat into spherical polar coordinates. So I am directly writing this form. You may not know this, that is cos theta r hat minus sin theta into theta hat. This is the most important part of the problem. Rest of the part is just use formulas, nothing else. Okay, and how you can get this is very easy to remember. If you forgot this, actually is this plus or minus, where is cos theta, where is sin theta, this is very easy to remember. See, this is the z direction. Okay, now suppose this is the radial direction, this is r hat. Okay, and theta you measure from z axis. Okay, this is theta. Now, how do you measure theta? You start from z axis and rotate clockwise. So, your theta hat should be in this direction. Okay. So, please remember this. This is z, and you are start rotating in clockwise direction. So, your theta hat should be in clockwise direction. Not someone may confuse that theta hat should be like this in this direction, but that is wrong. That is wrong. Theta hat should be in this direction because you are rotating clockwise from the z axis. Okay, so that's how you can now simply get that. Now z hat is equal to, if you take the component cos theta of r hat, you get that z hat, and theta hat sin theta, you get that z hat. So this is easy to remember from this diagram. Okay, so this is the formula. Now the first easy thing to calculate the electric field, because electric field is equal to minus grad phi minus del A del t. Now phi is not given, it is zero simply, so you have to calculate the del A del t, simply the derivative. Okay, and another thing you can do is this term u naught p naught omega by 4 pi, this part is a constant. It has nothing to do with the derivatives and curl grad, nothing to do with that. So let's take this as a constant k, so that your calculation will be little bit easier. At least it looks little bit simpler. Okay, so I am taking this term is k as a constant. Okay, so k by r, del t, so there will be a omega coming outside from the and sine becomes cos. Sine omega t minus rc becomes cos omega t minus rc. Okay, or there is a negative sign also, but doesn't matter. Omega t minus rc, and still here is z hat, so it is cos theta r hat minus sine theta theta hat. Okay, now comes the little bit, I will say not difficult, but you have to remember this. Okay, because these things are very handy for exams, competitive exams. So these handy things you should have remembered for the exams, because otherwise you can, this is a easy problem, but if you can't remember this handy formula, then you will not able to solve this in exam. So this is a very handy formula. Okay, so you know from spherical polar coordinates, if you read the curvilinear geometry for from your mathematical physics class, the first term h1 is 1, h2 is r, and h3 is r sine theta. So the product of the three terms goes behind in the denominator. Now there is r hat, there is r into theta hat, this h2 r is coming here, there is h3, that is r sine theta into phi hat, del del r, del del theta, del del phi. Okay, and there is a r into a theta, r sine theta into a phi. Okay, so this is the form. Now for our case, what is a? What is a? So k by r sine omega t minus r by c. So what is AR? AR is cos theta. The radial components only consist of cos theta. And what is A theta? A theta is minus k by r sine omega t minus r by c into sine theta. So these are the two terms. Now put it in the formula. Okay, r square sine theta, r hat, r theta hat, r sine theta phi hat, del del r, del del theta, del del phi. What is AR? AR is K by R. Okay, and sine omega t minus R by C into cos theta. This is AR. Mm, forward. So I am losing out of track, but yeah, this is the first column, this is the second column. Now r a theta minus k sine omega t minus r by c sine theta, and finally 0. Okay, so now if you look at the r hat part, it is del del theta into 0 minus del del phi into this term. It is phi independent, so r hat has no contribution, so it is 0. Now look at r theta hat. Okay, so del del r into 0 minus del del phi into this term. So again this has no contribution. So final contribution coming from this part, r sine theta phi hat. Okay, so r sine theta phi hat divided by r square sine theta. Okay, now take the derivatives. So del del r into this. So if you differentiate with del del r, firstly the sign will change to cos. Sine omega t change to cos omega t because r is inside the sine theta. Okay. So sine will change to cos, and what is the coefficient of r? Minus omega into c. So minus omega into c come outside, and it will multiply with minus k. So it will become omega k by c. Okay. So omega k by c cos omega t minus r by c. This is the first term. And the next term is minus del del theta into this. Okay. So del del theta will change the cos theta into sin theta. Okay. Okay. So plus k by r sine omega t minus r by c into sine theta. Cos theta changed to sine theta. But the thing is, look at now this term. Look at now this term. It will 1 by r, and there is something in the bracket. Now 1 by r, and there is a second term 1 by r. So the final contribution will be 1 by r square. So this term will nothing contribute to the radiation field, because we know the radiation fields are proportional to 1 by r. They should be proportional to 1 by r. That's why the total intensity is independent of distance. Okay, so this term will nothing contribute nothing, so we can neglect this term. So only this term will contribute. Okay, so omega k by c cos omega t minus r by c, and don't forget this is a phi hat. Okay, okay. Now what is your s vector, pointing vector is equal to 1 by mu naught e cross b. Okay, now you have your e, you have your e, this is your e. Okay, and this part is there, but remember, your e is r hat into theta hat, and b has the direction phi hat. Okay, so if you do e cross b, then r cross phi will give you the direction of minus theta hat or theta hat, whatever. But you should know that your pointing vector, as I told earlier, but it should be radial, should be a symmetric, I mean central thing. Like your power should be radiated uniformly in radial direction. So your pointing vector should be in radial direction. Okay, so you should take contribution only from this theta hat part. Okay, because your theta hat into phi hat will give rise to r hat. So should take contribution only from this theta hat part, not from the r hat part. Okay, so what is your now e is your k by r. Let me k omega into r. Okay, k omega by r cos omega t minus r by c. Your sine theta is there, so there will be a theta hat, sine theta theta hat, cross product into b. Now b is this omega k by rc, omega k by rc cos omega t minus r by c. Okay, there should be a sine theta also. Did I miss something? Yeah, I missed this del r will act on this, but there is extra sine theta. I missed that. Sorry for that. There is extra sine theta. I missed that. You can recheck the calculation. Sorry for that, but there will be extra sine theta. Okay, so there will be a sine theta into phi hat. So now your theta hat into phi hat gives rise to r hat. So your final pointing vector will be in this direction. Now k square 1 by mu naught k square, that is mu naught square p naught square omega square into omega, there is a 2 omega extra here, so omega square into omega to the power 4 by 16 pi square c r square sine square theta into cos square omega t minus r by c. Okay, so this is your pointing vector. Now what is your average power? Average power is now s dot dA, or area vector, 0 to r. Limit of r is 0 to infinity, and limit of theta is 0 to pi, and limit of phi is 0 to 2 pi. Okay, so this is your limits. Okay, uh, yeah. Now your r square will be get cancelled. Okay, so there is sorry, there is not 1 by r square here, there is 1 by r square here. So r square get cancelled, and your final answer will look like this: mu naught p naught square omega to the power 4 by 32 pi square. See why I am writing 32 here? Because average of cos square omega t minus omega r by c, this average of cos square is half, so the extra half is coming here. Okay, So there is sine cube theta d theta 0 to pi. D phi, integration of d phi gives rise to 2 pi. Okay. So this thing will be 4 by 3. So mu naught p naught squared omega to the power 4 by 12 pi c. This will be your final answer. And if you don't remember that what is this formula, this is easily can be done. This is you if you know the beta functions, okay, the beta, gamma and beta function, then there is a easy formula. Sine to the power p theta into cos to the power q theta d theta 0 to pi is equal to gamma into p plus 1 by 2 gamma into q plus 1 divided by 2 q plus 1 divided by 2. Sorry, it is messy, it looks messy, let me change it. Q plus 1 by 2 divided by gamma p plus q plus 2 divided by 2. So this is the formula. I mean, I remember by this formula, but if you have any other techniques you can go with it, because you can also do with this trick, that is sine 3 theta is equal to 3 sine theta minus 4 sine cube theta. So you can also go with this. Okay, so this will also work here, but how whatever may be the technique. So this is the answer. So the thing is, you have do a little bit of calculation here, but nothing complicated here. So this type of problems is easily done, easily can be done in exam hall. So please read this radiation thing a little bit, because you have to give a little bit of effort, little bit of time upon this, and you can solve problems from this. Okay, so that's it for today, and next video we will do another PYQ. Thank you.